Welcome back YouTube, Muskasar here once again, and for today's video we will be seeing an interesting new method of calculating the area of a certain polygon. Now, there are a few conditions that this polygon needs to meet. First of all of the edges must be straight, meaning we have a polygon like this with this one irregularity over here. Because of this, the edges are not all perfectly straight, and this will not work. Secondly, the edges must not cross or overlap each other, meaning shapes such as this do not work. Alternatively, shapes like this are needlessly complicated since these overlap each other. Though with this one you can just select the 3 points in the triangle and you'll be there. So yeah, given these two rules, the only other rule you'll need is to know where each of these points are on the grid. In this case, we can easily see thanks to the labeled axes. And given this, we can get straight into this. So now the first order of business is to find any random point you want and make that your starting point. In this case, I'll choose this point over here, x coordinate 5, y coordinate 1, and make that my starting point. After that, you can go in either direction and then select the next point after that, meaning this, or the exact opposite direction. However, you must select the next points as they come along. So in this case, I'll just do B, C, D, and E, given that they're all in the correct order. Again, you can do clockwise or counterclockwise, though the fact that they follow in order is the only real important thing here. And given all of that, we can get straight into this. So then we label all of our points in a neat little table thingy. So you label A, B, C, D, E in the correct order, and then you label the first point one final time at the end, and you'll see in a minute why we need to do this. So then we label our points here. For example, as I mentioned, this is 5, 1. B is 3, 3. C is -1, 1. D is -3, -2. And finally, E is 2, -4. And then with A being 5, 1 again, the same exact point have to be on the top and bottom. And now let's draw some shoelaces across. Now you want to draw these shoelaces precisely such that the x-coordinate of one number, the x-coordinate of one point is linked with the y-coordinate of an adjacent point, meaning in this case the x-coordinate of A is with the y-coordinate of B, x-coord of B with y-coord of C, and so on and so forth. Now, if you want, you could choose to do this all in the same color. However, I chose to do the different directions for shoelaces in different colors, and you'll see why right now. And once you finish drawing your shoelaces, you now have a shoelace between two separate numbers. For each shoelace, the value is the product of the numbers, meaning, for example, you have 5 times 3, that's 15. Over here, 3 times 1, that's 3. -1 times -2, that's 2. -3 times -4, that's +12. Again, you want to be careful with your minus signs, since a minus times a minus is just cancelled out. And finally, you have 2 times 1. Given all of this, you know that the sum is 34 of all of the shoelaces. And then we do the same exact thing for the opposite direction. Now remember, you only add the downward diagonal shoelaces with each other, and the upward diagonal shoelaces are processed separately. I mean, you still use the multiplication thing to get 3 times 1 equals 3, minus 1 times 3 is minus 3. Minus 3 times 1 is again a minus 3. Minus 2 times 2 is minus 4, obviously. Finally, 5 times minus 4 is minus 20. So then we have minus 27. Once you find both of these numbers, you subtract one of them from the other. In this case, I'll choose to take minus 27 away from 34. And if you notice, we have these two negative signs, which means they cancel out to just become plus. So 34 plus 27, that becomes 61. Now, if you did it the other direction, or you swapped the x's and y's around, you would probably get minus 61. However, that is perfectly okay because we need to take the absolute value of this number, the difference between the two shoelace sums, and then we need to divide this by 2. This gives us then our desired total of 61 over 2 exactly, or 30 and a half, or 30.5 units cubed. Or squared. Did I say cubed? I meant squared. And that's really all there is to it. This is the solution. So yeah, I hope this explanation was helpful. Again, make sure that if you're trying to figure out the area of your own shape, that it follows these rules and that you know exactly the exact coordinates of the positions. If you do, then you can use this method with any number of points, be it say 5 or 500, and you can figure out the exact area. Though I imagine with 500 you'd use a computer, but your choice. In any case, this has been Muskasar, and I hope you enjoyed the video. If you liked it, please let me know what you liked about it. If you felt I could improve my content, please let me know down below what I could improve in it, and I hope you enjoyed this video.